Hello, 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 hello. Am I audible? Hello, Mr. Gopal Krishnan. Hello, Mr. Gopal Krishnan. Hello.
Yes, sir. Able to hear, sir.
There was no response, so I didn't know.
Able to hear, sir.
Hello, Mr. Gopal Krishnan.
Yes, sir.
Is the screen visible now?
Yes, sir. Yes, sir. It is visible, sir.
Okay.
कृष्णा जरूर की पूछना आपका कार्ड प्लेस बहुत ज्यादा अच्छा है ये
Yes, sir. Thank you, Kandra. Yes, sir. Half an.
ஹலோ
ஹலோ.
இல்லப்பா
Good afternoon to all.
Yeah, good afternoon.
Good afternoon, sir. On behalf of the Institute of Indian Foundry Man, the National Center for Skill Development, and the EHS Committee, it gives me immense pleasure to welcome you all to this joint webinar on occupational health and safety aspects of foundry operation. Foundry operations form the backbone of our manufacturing ecosystems, but they also involve significant occupational health and safety challenges. Issues such as exposure to heat, dust, fumes, and molten metal, noise, and ergonomic hazards demand constant attention, systematic control, and a strong safety culture. This webinar has been thoughtfully designed to enhance awareness, share best practices, and reinforce the importance of proactive safety management in foundry environment. We are indeed privileged to have with us today Mr. Govind Pitre, an experienced trainer and consultant, as our guest speaker. His rich industry exposure and practical insights into occupational health and safety will surely help participants to understand the real life risk and effective control measures applicable to foundry operations. Mr. Govind Ramachandra Pitre is an accomplished professional with unmatched track record in spearheading cross-functional roles encompassing occupational health, safety excellence, sustainability management, and corporate social responsibility. Proven experience in formulating and implementing various initiatives for achieving corporate strategic goals, targeting to express potential top level leadership roles within an esteemed organization. His core competencies include ESG implementation and reporting, sustainable procurement, compliance and safety audit, incident investigation, safety training programs, zero waste to landfill, SOP formulation and implementation, BRSR, corporate social responsibility, EHS and fire audit, team management, and leadership. Leadership skill. We warmly welcome all participants, industry professionals, safety practitioners, engineers, and supervisors and students who are joining this webinar today. Your presence reflects a shared commitment towards creating a safer, healthier, and sustainable workplace in the foundry sector. I encourage everyone to actively participate and make the best use of this learning opportunity and carry forward the insights gained today into your respective organization. Once again, I welcome all and wish a great webinar today. I now the floor is for the trainer, sir, Govind Pitre, sir.
Yeah, so good
Yes.
afternoon all and welcome to this 1.5 hour interaction. Because I would not call it as a training session because most of you are well established, very highly experienced practitioners in foundry operations. And I also want to apologize that this program was to happen on 12th of December, but due to sad demise of my mother on 8th of December, we had to reschedule this program. And Mr. Gopal Krishnan was very kind enough to accommodate and understand the situation and help us. So thank you all and let us start. Okay. So basically the agenda that we would like to cover as much as possible, because sometimes if the interactions go intensely, then time becomes a little constraint, but we will try and cover most of these issues. So we will first see what is the critical need for occupational health and safety in foundries. Then what are the major hazards which Mr. Gopal Krishnan shortly touched upon. So what are the overall foundry-wide overview, different operations, what kind of risks it emanates, and what kind of risk mitigation measures, okay, we need to implement in the company. Third is the health risk, because many times people talk a lot on safety, but when it comes to the occupational ill health, foundry is one place where many risks are there for health as well. It is an invisible enemy because the results are known only after some time. Then we will also see what are the how we can utilize the international standards on systems for occupational health and safety for foundry operations. Then we will also see some good practices. What could be the technological interventions, future trends, and what should be the roadmap to achieve zero harm. Let me tell you, I started my career on 15th of December 1986, and the first shop where I worked was Foundry. And from 2009 till 2020, for almost 11 years, I was heading corporate safety function in Mahindra and Mahindra Systems and Technology sector, where one of the critical units was SGIN Foundry. So that is a little background that I have. I am a mechanical engineer, and having served for over 37 years in various fields, prime contribution was in safety, sustainability, and systems. So with that background, let us start the session. So the first session is about, what is the condition of foundry, what is the importance. So if you see the global stature and scale of foundry operations in the world, it is the second largest producer of castings globally after China. This is for India. Okay. India is the second largest producer of castings after China. It comprises an estimated 4,500 to 5,500 foundry units, including large foundries like Tata Group or Mahindra Group, including some of the steel manufacturers are also having their own casting operations. But apart from that, there are many small, medium scale companies, in foundry. Not just gray iron casting, but SG iron casting, aluminum castings, and many others. Annual production capacity of Indian foundries is estimated to be between 11 to 12 million metric tons. Okay, that is the contribution that foundry does. Over 80% of foundries are classified as medium and small scale enterprise. So, the turnover about 100 to 500 to 1000 crores. This structure presents a unique challenge for implementing standardized OHS practices due to limited capital for investment, informal workforce, and training gaps. Now, why this informal workforce? Because foundry operations requires people with strong muscles, ability to work for longer durations, tenacity, and also people who can adjust themselves to various hazards. Okay, so and not only that, there is no separate school or ITI especially for foundry people. Very few ITIs are giving this training, and the hard work that needs to be done is something unique which very few people are able to absorb the kind of stress and strain that the work involves. This is a highly clustered kind of a thing. They means people work together. Major clusters are in Western India. It is in Bhopal, Rajkot, Metoda, MIDC, GIDC. Ahmedabad, Kolhapur, and also near Kolhapur, that is Belgaum, Sangli, and those areas. Southern part, Coimbatore, Chennai. Northern part, Agra, Faridabad, Jalandhar, in Punjab, and east side in Kolkata, Howrah region. So these are prime clusters, not that other places the foundries are not there, but major foundries are concentrated in these parts of the country. Some of the sectors that it serves, the prime is automotive sector where 65% of the demand is there for engine blocks, the gearboxes, housings, axle gearbox housings, including the uh, transmission related areas. So those are areas where automotive related demands are there. Capital goods and machinery for machine tools, etc. Then infrastructure and construction sector. Then railway, the major customer is railways and domestic appliances. So domestic appliances is very less for cooking purpose, etc. But otherwise, the major work is in automotive demand. So this is how the pictorially that we have tried to put in on the Indian map. The backbone of Indian manufacturing, the foundry, facing critical OHS challenges. OHS is not just a regulatory need, but a strategic imperative for the sector's sustainable future. Now, sustainability, the word sustainable here it has come because it takes care of environment. The foundry has got major environmental concerns, and in the previous session, we have deliberated it quite in depth. The second aspect is the social part where occupational health and safety uh, is included. And the third is part is economic and governance principle, how we operate. So if we are not careful, if we are not having proper systems and discipline, then all the three areas, environment, social and governance, on all the three fronts, the organizations can fail. And the contrary to that is if we take care, then our prosperity will always be there, our safety performance can be enhanced, and on environmental regulations also we can go beyond the regulatory norms. So rather than looking at it as a challenge, we prefer to take it as an opportunity to contribute for environmental protection, for OHS excellence through injury prevention and ill health prevention, and also, in the difficult area, if you excel, okay, that gives you a brand image, a goodwill of the people. So in all the fronts, while there are risks, but positive, proactive people take this as a challenge and as an opportunity. So why OHS in foundries is non-negotiable? Okay, no one can ignore it. Okay, first is the human cost, preventing fatalities and life-altering injuries. During my tenure in CIE Automotive in Pune, I have seen in 10 years at least 3 to 4 incidents where person had to lose his life. Another 2, 3 incidents where major amputations happened, burn injuries occurred, and of course, ill health, what happens is most of the times the illness is not known very early unless the medical health checkups and their reports are recorded very honestly. and those are analyzed properly. So that is a challenge area, because no company wants to tell the world that my foundry is creating so many notifiable disease affected people. Fatality they cannot hide, because police people are there, the social people are there, other people are there. So nobody can hide much. Second is combating occupational diseases. So this is related to silicosis, the hearing loss, the the because of vibrations. Okay, there are many issues. Poisoning and toxicity, because when you make molds and when you make pores, uh, lot of certain binders and chemicals are used, and if they are not properly handled, they can create situations. It is the moral duty to protect our greatest asset, that is people, and Section 7A of the Factories Act, where the roles and responsibilities of the occupier are clearly mentioned. When it comes to hazardous processes, dangerous operations, hazardous chemical applications, naturally these aspects become very vital, because otherwise the occupiers have to face the court cases, very huge amounts of compensations have to be paid, and the legal procedures drag quite a lot. Occupational Health and Safety Directorate Office will also give them show cause notices which they need to handle. So a lot of effort goes in after effect of any serious incidents. So that is why, to if the top people are saying that people are our assets, then by constitution, by law, by the Factories Act alone, the impact is very high. Second is the business case, how these accidents or safety issues are related to the financial performance of the company. So how does it make a business case? Both ways, if you do and avoid accidents, how does it help? And another is, if you are complacent and if your systems are loose, then accident rates will be high, the severity rates will be high, and then the costs incurred in insurance, the equipment downtime, and other things are very high. A good company which takes care of safety, it reduces the downtime, it reduces the insurance cost, it boosts the productivity, quality, and morale, and protects corporate reputation and ensures compliance. Now here, many times we have seen that nowadays people do not look at only the pay package, but they also see how safe it is to work in a particular company. So Foundry, if the reputation is bad, then attracting good talent from outside becomes relatively difficult. The third aspect of why OHS is non-negotiable is the legal perspective and social imperative. Imperative is something which is mandatory. One is the mandatory under the Factories Act, as I was telling you, under hazardous processes and dangerous operations. Second, it is ethical responsibility and social license to operate. That means if the performance is perpetually bad, naturally the pressure will come from all the stakeholders, including the customers, the investors, the legal bodies, uh, and the company has to face very serious times. So the combination of various hazards like extreme heat, Mr. Gopal Krishnan was mentioning, heavy materials, toxic fumes, airborne dust creates a perfect storm of hazards not found in most other industries. Similar, if you want to draw similarity, it is the steel industry. This makes a robust OHS system not just a best practice, but an necessary for the survival of the business and its people. Okay, so I have seen it, I have calculated the cost of accidents, and I would like to tell you some of the accidents which happened. I have investigated in foundry operations. In one of the incidents, the hazardous waste, empty containers of chemicals, they were piling up, and company decided to gasket and then dispose as a metal waste. So during the gas cutting operation, suddenly an explosion occurred because some chemicals and the flammable fumes were accumulated in that tin, and because of the explosion, the person died. Another incident where in the molding sand belt conveyor, okay, in that for some reason repeatedly the sand was getting stuck and belt was getting interruptions. So the worker went underground to look at the problem, and he, to remove the sand, he put his hand inside the system and he got drawn inside the uh, part and hole and got killed. Another incident which I saw where the hand amputation occurred is in the core making operation. During the Bhaubij, or you can say this Nadli Purnima, people, there is a Bhaiya Dooj, or what they call it as Shravan Purnima. On that, the sisters tie the uh, thread onto the hand of the brother. Okay, and that thread got entangled with the pin in the core box, and he could not remove it while core operations, and entire palm got amputated. Okay, similarly, during the machining operations also we have seen some of the incidents. During sand handling, incidents have happened. And very surprisingly, one incident where one of our senior managers got crushed and died is he was standing behind the truck and talking on the mobile phone. And the driver, who had gone to submit some of the commercial documents to the stores department, when he came back and he reversed, he did not know that somebody is behind the vehicle. And this officer who was talking on phone got crushed. So some such incidents can happen. Okay, so we have to be very careful, and hazard identification, risk assessment, risk mitigation, those things become very, very important in powder. So let us understand the hazards. So first is the pattern making. Okay, that is creating a replica of the final casting, typically from Mr. Gopal Krishnan. Can you request all the participants to be on mute? From Mr. Gopal Krishnan?
Yes, sir. Yes, sir.
Yeah, please ask all the people to be on mute.
Okay, sir.
Yeah, creating a replica, that's the pattern making operation what we do, typically from wood, metal or plastic. So what are the hazards? The machinery hazards, solvent vapors from adhesives, repetitive strain, dust from the operations. Second is after pattern comes the molding and core making. So packing refractory sand around the pattern to create a mold cavity. That's the molding operation. During this, there is a risk of silicosis because lot of exposure to flying dust, flying sand. Then fumes from resin binders, okay, heavy manual lifting of mold boxes. Nowadays, lot of automation, mechanization has happened, but still in small foundries, this heavy duty material handling still continues. The most important operation is the melting and pouring. So melting metal is melted in a furnace, either cupola, induction furnace or arc furnace, and there is an intense radiant heat. Metal fumes, high noise from furnaces, there is the risk of fire and explosion. I have seen this fire occurring in the molten metal area, and even though all around the sand was there, okay, people were trying, but the explosion was so huge, you know, there was a substantial loss in the organization. Then the pouring operation, after molten metal is available, transferring molten metal from furnace into the prepare molds using ladders. Okay, that is the operation. So what are the hazards? Extreme burn hazards, intense radiant heat, hot ladders, strain and burn injuries. These are some of the risks. Every step in the foundry process introduces unique risks to worker health and safety. Understanding this flow is the first step in risk management, because unless you are aware of what can go wrong, what are the hazards, how injuries can occur, the person will be unaware, and because of ignorance, people can make mistakes. Next step is cooling. The casting, once the molten metal is poured, the next is cooling. That is allowing the filled mold to cool and the metal to solidify. Okay. In that also there is a lot of radiant heat, because the heat is dissipated from mold, off gassing from burning sand binders. Next comes the shakeout. So breaking apart the sand mold to retrieve the solidified casting. This is where a lot of vibrations are there. Extreme levels of silica, dust, high noise, and handling of castings. Heavy castings which are inside the mold, those have to be taken out. Then comes fettling and finishing, where extra projections are removed. Removing excess metal using grinders and chisels, where metal dust, residual silica dust, high noise from grinding, vibrations, high injury. And in this area also we have seen a major fatality occurring because of the broken grinding wheel. Okay, and whatever the job, such areas, the jobs are outsourced, most of the time subcontracted. The contractors may or may not be using right quality helmets, and in that process the broken grinding wheel hit the worker and person died. So this is critical area where incidents can occur. Next is the inspection and dispatch, where checking the final casting for defects and preparing for shipment. So here there is a manual handling of finished castings, cuts from sharp edges, slip, trip, fall kind of hazards can occur. many companies do additional value addition, that is machining part also many times. Semi-finished or fully finished castings are given. So in that, machining related hazards can also arise. So what are the physical hazards? One is thermal, another is noise. So a lot of noise induced hearing loss can occur. And even though you can say that you may put some earplugs or you know, different other gadgets, but in that process, what happens is on shop floor, communication becomes difficult, and the worker or whosoever engineer will have to talk in louder tone. Right? In the process, they develop the habit of speaking loudly, and that continues in home also. And house people are surprised as to why this man is shouting. Okay, that another hazard. Machinery and movement and slip, trip, fall. These are some of the hazards, physical hazards. So we have already seen from where these hazards are arising, especially slip, trip, fall. We had not seen much. So cluttered and wet floors, so housekeeping becomes important. Poor lighting, because even though you may put good LEDs or others, because of the sand and flying dust, the lighting, effective lighting becomes very challenging. It can trigger major incidents. The slip, trip, fall, if the fall is in the machinery area or in melting area, it can trigger another effect of further multiplying effect of serious accident. So these are some pictorial representations of what kind of hazards are there in foundry. So in the gas cylinders, there are certain gases which are used for cutting, etc. So that is toxic gas, extreme temperatures, electricity related hazards in induction furnaces and others. Then because lot of air pipes are there on ground, slip, trip, fall can happen. Even lot of sand is there on the floor, so slippery floors can create issues. Exposure to harmful substances, like we saw some of the chemical examples. Confined spaces, especially the one which I told, that molding sand, the conveyor clearance, that is normally done underground. There are confined spaces in which incidents can happen. In electrical areas, there are high risk equipment, induction furnaces, arc furnaces, electric overhead, traveling cranes. Cranes is one of the important areas in foundries. Cranes do create serious incidents of, if the magnet falls, okay, the scrap which is lifted in the input area, if the magnet fails and suddenly falls on somebody, will get killed. Okay. Then motors, different motors, high capacity motors are being used. Portable grinders, yeah, as I told you, one example. So some of the hazards that are here are electric shock and electrocution. Contact with live parts can cause severe injury or death. Then electrical fires and explosions, short circuits, overheating or faulty wiring, igniting combustible materials. Then arc flash causes severe burns, blindness, hearing loss, and fatal injuries. And equipment failure leading to catastrophic failure and molten metal runout. These are some of the serious hazards which are posed because of electricity. So what is required is LOTO, insulated gloves, arc rated PPEs, circuit breakers, and proper inspection before use. And of course, the LOTO system, electrical work permit system, these are some of the control measures that can be implemented. Then next type of the engineering controls that we can have is proper grounding and bonding. The electrical engineers would be able to understand it better. Electrical panel safety, so arc flash studies, etc. we need to do. Then IP ingress protection. So there are various grades, various types which we have to select appropriately for our purpose. Then residual current devices, ground fault, circuit interrupters, that is, and earthing systems, adequate wiring and insulation. So proper laying of cables and proper MCBs protection, that is all required, and especially in the sand area, mold area, where these electrical panels can get badly affected because of the sand, okay, and heat. You have to protect them with proper care. Another is administrative controls, where personal attention is important. Administrative control means where we are depending on personal alertness of the people. Okay, so one is the lockout tagout system. Many people initially learn it, initially purchase the kits and start, but when it comes to consistency and discipline, many people fail. Permit to work for all high risk electrical work, like shutdown areas. Regular inspections and thermography study for understanding how the electrical panels are getting affected and take proper correction. Training and authorization system. Okay. So this is again administrative control. Permit to work is an administrative control. And of course, you have to have competent people. Okay, they are properly qualified by their education, experience, training, and also the legal qualification from the government office. Last one is personal protective equipment, where we need to use voltage rated gloves, arc flash rated clothing, and safety shoes with electrical insulation. Many companies we have seen, they do not conduct arc flash studies. Many people do thermography study, but arc flash study is conducted by very few people. But this is very useful to avoid serious incidents, not only in the LT panel area, but also the other resultant losses. Third aspect is chemical and atmospheric hazards. This is a invisible threat. The sources we have already seen in silica, which molding sand, shakeout, fettling, which can result in silicosis. If you go to YouTube, just put the search silicosis in Foundry, and the kind of pain, kind of loss, ill health that people have to suffer because of silicosis and TB, tuberculosis, is very serious and nobody should have it. The second is metal fumes. So source is melting and pouring, like zinc metal fume fever, manganese neurological damage, loss of memory, okay, and lead poisoning. Okay, so these things can happen, and long term it happen. You will come to know only after 15-20 years. By the time it is irreversible, And many people, what they do is they remove the people from the job, showing some other indiscipline issues, and leave the people to manage their own. So that is something which is absolutely unethical and unacceptable. The third is the toxic gases. Carbon monoxide, which is odorless, it causes asphyxiation. That means lack of oxygen. Sulfur dioxide, severe lung irritant, and formaldehyde, ammonia from binder systems, carcinogen and irritant. Carcinogen means long-term cancer it can create. So these are all very invisible areas, but long term they give very bad effect, and that is why notifiable diseases under third schedule of the Factories Act, they talk about all these different diseases, and that is why Foundry has been identified as a hazardous process and lot of precautions are required to be taken. Next part is, these are some of the pictorial representations of what we just discussed. If you see, what we see on ground is a heap of sand, but actually what enters the lungs of the person are small tiny particles. So even microscopic particles less than 10 microns penetrates deep lung tissue and causes irreversible scarring, that is silicosis. So inside the lungs it affects seriously, and capacity of the person to breathe air, take oxygen and transmit it to the blood purification process becomes very difficult, and in the process the person becomes weaker and ultimately dies. Next is the ergonomic hazard. I think Mr. Gopal Krishnan was talking about ergonomic hazards. Ergonomy is science of how body parts function, okay, and how to take care of the body movements, okay, so that you don't create the relevant ill health. So first is manual handling, lifting, heavy molds, castings, chronic back injuries. And what happens is the contract people, because they have to work, okay, because they come from distant places, and their job is very hectic, they get tired, they don't have proper food arrangements, and they stay also very crowded places, 4, 5, 6 people in one small room, no proper bathing water available, etc. So their condition is bad. So normally they tend to get into the alcoholic consumption, and then it multiplies the problem. Vibrations, MSDs means vibration related syndromes. Repetitive tasks like grinding, ramming, carpal tunnel. So these are various issues, because of the grinding, especially when it is hard, you are pressing the grinding wheel onto the casting and trying to remove the material. They don't know, what is the structure, whether the grinding wheel is properly balanced, and how much pressure to put. Sometimes it gives way and creates serious accident. Awkward postures. The ergonomic is related to awkward postures, bending, overwork, spinal and muscular damage. This can, this is a, and many times it is irreversible. Okay. These hazards do not always stop work immediately, but they slowly stop the worker. The ergonomic hazards and biological welfare hazards like physical strain, poor hygiene, okay, because Normally what happens is these foundry people, normally because they are working so hard, they overeat. Okay, because the stress has to be relieved somewhere. So when they get food, they will overeat. They eat normally the spicy food. Okay, and many contract laborers, they are given only one meal, but they are working for 12 hours. So naturally in the evening they will get hungry, and then they will get something from nearby, small shop, which is very inhygienic. Okay, they eat it because they need it, but actually if the company is giving them 12-hour work, then two breakfast arrangements also have to be made by the organization. Now the new OHS code is trying to put little more responsibility onto the occupiers, but we need to see how it gets translated onto the shop floor. Poor sanitation spreads infectious diseases where they stay. Lack of washing facilities leads to ingestion of toxic metals. Skin diseases, no access to clean water causes dehydration and worsens heat stress. So foundry operations, because they are exposed to continuous heat, by law also it is mandatory that cold water, clean water and very easily accessible places, water should be made available, and those water tanks have to be regularly cleaned up. The it has to be properly earthed, otherwise in sometimes we have seen even electrocution have happened in the water coolers also. Okay, so proper ELCB, with proper rating, 30 milliampere cutoff rating, that is also required in water coolers. These are some of the pictorial representations where how people stretch, okay, back injuries, then here neck, hand, okay, many parts of the spinal cord, joints, how they get affected. Then many times they have to use very heavy objects, sitting posture is very awkward. So with all these, even the people who work on the roofing, they also many times work with different ergonomic awkward situations. So all these, and mainly continuous 10 hours, 12 hours, these people every day they are exposed. Most of the foundries work at least for 6 days in a week. So, that is the kind of up to 72 hours people work in a week in a difficult situation. So all these create different ergonomic and biological hazards. So this is the summary of how different kinds of hazards are happened. 80% of serious risks are concentrated in 20% of the floor space. A targeted strategy focusing on these four zones will yield the greatest safety return on investment. So especially the melting area, the checkout area, material handling and fettling grinding. These are four areas out of entire foundry which are most significant. Pareto principle, 20% of areas creating 80% of risk. Let me take you to some of the incidents. This is the case: 1 killed, 5 injured in furnace blast at Pelakur steel plant. Tirupati district collector directs company representatives to provide a compensation of rupees 25 lakhs. Nowadays, the compensations have gone up to 45-50 lakhs also. And lot of political intervention, union intervention, local people intervention further aggravates the situation. And this is apart from what they get from PF or other insurance that company takes, but this is a direct compensation companies need to make. And even beyond that, if the court directs further compensation, the company has to obey. Okay. So this is the one example. Another, two killed, one injured following explosion in casting furnace in Agra. Another 18 workers injured in accident at steel plant in Varda, in Maharashtra. The incident took place in furnace area at Evonith steel plant on Bhugaon Link Road during the process of cooling of slag. At least 18 workers got injured. So I was there for ESG assessment of this company about 2 years before, and I went through the details how very serious issue they had. Nagpur factory blast, safety lapses found, 3 booked. So it is 3 booked means normally the occupier, the factory manager, the maintenance manager, the safety officer. These are the people who are normally arrested. Of course, after that you pay the fines, etc. For some days you may be behind the bars also, and there is a lot of social pressure from employees, from union, from local people, from family members, from media. Nowadays media creates a lot of further complications. So all these things, these are the ill effects of mismanagement of foundry operations. So therefore HIRA becomes very critical. So manufacturing of HG iron, grey iron, alloy steel and carbon steel, some of the processes that we already seen. And HIRA means hazard identification and risk assessment. And afterwards you have to determine the risk control measures. Okay, that is the planning part. In implementation operations, we have to meticulously execute the SOPs, the permit systems, the standards, whatever company has decided. So methodology for HIRA, first is identification of hazardous materials. So the people who do HIRA in foundry, they should have at least 5 years experience, because the young people, fresh people from engineering colleges, or just because somebody is a mechanical engineer who has worked in automobile vehicle assembly plant, if he goes to foundry, he will not know ABC of it. So practical experience, working on ground, okay, facing those hazards and learning properly through technical literature and on-job training, that is very essential. And of course, the experienced people should add lot of value in HIRA. So then process hazard analysis, especially in the molten metal related areas. Then we have to do the consequence analysis. So what can go wrong, how much loss it can have, whether the consequence will remain only to injury or it can create amputation, blindness or dumbness, or it can create fatality, multiple fatality, fire, property loss, all those things. And risk categorization. So normally we categorize, intolerable, substantial, moderate, insignificant, trivial, etc. So that we need to do. So major fire and explosion hazard. This is one example of one company. Okay, what kind of hazards were identified? One is the major fire and explosion hazards. Induction furnace, then LPG storage area was a major hazard. Now this can be in the facility management area, but LPG storage alone can create a very serious, because major accident hazard units, they have their own issues. Then fire impinging on an LPG cylinder could cause a blavy. boiling liquid, expanding vapor explosion. These are all, studied in quantified, quantitative risk assessment, QRA studies, process hazard analysis. So there these levy, etc. is studied. Second is power transformer contains a large quantity of insulating oil which can catch fire due to electrical faults. So transformer fires are also very important. As well, the structural stability of the platform, concrete floor on which the transformer is placed, that is also equally important. Second is toxic release and health hazards. Incomplete combustion in LPG systems or processes can release colorless, odorless carbon monoxide gas, leading to asphyxiation in confined spaces. This in kitchen also, in home kitchen, if there is no proper ventilation to the kitchen area, because of cold, if the ladies are putting all windows closed, this can happen. Even in the LPG based water heaters in the bathroom areas, many times the CO gas accumulation, asphyxiation creates fatalities. Generation of respirable crystalline silica dust during molding, sand handling and shakeout operations, and metal fumes we have seen. Then high noise levels risking noise induced hearing loss, exposure in melting and pouring areas, spills of oil, chemicals or molten metal could potentially contaminate soil and water if not contained. One accident I want to share with you. On weekly off, the maintenance people had repaired the hoist motor. Okay, and the hoist was used to lift the ladle and then taking it to the molding box. What happened is one of the pins which has to be put during the fixing of the motor, that was not put, and as they started the operation the next day, after half an hour, the entire molten metal ladle failed because the hoist failed. Okay, and the entire area was full of molten metal. Some of the people who were there very near to that, they had very serious burn injuries, apart from the loss of molten metal and other hazards. So these things can happen, and they do happen. So what are the engineering controls? First is provision of fire water hydrant systems, water sprinklers, foam pour systems at LPG storage area. Then second is melt leak, so ensuring proper furnace lining, refractory quality, regular inspection, and providing a bund wall, dry pit around the furnace, so that even if some overflow of boiling metal is there, it will not spill everywhere, but it will get contained into that bund wall. For dust hazard, installation of back filter based dust extraction systems at all dust generation points. This we saw during our environmental session also. The next is the administrative and procedural controls. So one is the strict enforcement for hot work and confined space entry, but again it depends upon the discipline of the people. Development of detailed on-site, off-site emergency plans, doing mock drills regularly and training people how to handle emergencies. Then comprehensive training for all workers on safe operating procedures, safety standards, hazards of various materials, and how to respond in emergency situations. And implementing a periodic health monitoring program for the workers through proper agency reputed, and the qualified medical services, so that their reports can be relied upon, and the proper analysis of these medical reports can give proper guidance to the top management as to what corrective preventive actions are required. And lastly, the PPEs, mandating and providing respirators, heat resistant apparels, safety glasses, face shields, hearing protection to all workers, then foot protection, leg protection. So even the melting area, the entire body is affected because of hot metal. So proper PPEs from good companies, reputed companies with proper IS code have to be provided. Many companies, because the contract laborers are there, work is contracted out, subcontracted, they do not give proper attention to PPEs, and that is a crime, I would say, because you are, dangerous, dirty, difficult jobs you don't want to do, you want to outsource it. And even in that, you will not take care of the people. That means your wealth is not a very ethically earned wealth, which will not really be giving you benefit on the long term. It can, the people's curse will have its adverse effects on companies' long-term sustainability. Let us take another incident of uh, safety. This happened in Nagpur. Nagpur factory explosion, death toll climbs to 5. This is in April 12, 2025, just last year, few months back. Deceased workers, all in the age group of 20 to 25, were residents of Nagpur district. A fatal incident occurred in the Umred MIDC area, where 5 workers died and 2 others were critically injured. Cause: a report by the Directorate of Industrial Safety and Health found the factory failed to provide necessary PPE and assigned 2 recently recruited workers tasks without any safety training. This is, even though they have said PPE and training, which are last leg of the injury prevention, but if you really dig, if you really analyze why this was done, okay, why the ill-trained or untrained young people between 20-25 without proper on-job training are being assigned the jobs with very high significant risk. This shows the attitude of the top management, the carelessness, the culture of the company. Another Evonit steel, we spoke about it. The exact cause of this incident is still under investigation. What I knew is during the shutdown operations, okay, something, the system was not followed, and the accumulated, the energy got released suddenly, and that killed 18 people. The investigation will determine if it was due to industrial negligence. Now, they are not very clearly coming out. Now, see, hazards, specific risks and key controls. I think these we have seen more or less through, spill containment, dry tools, SOPs, aluminized PPEs for molten metal areas, proper ventilation, water misting so that the dust doesn't fly, okay, vacuum cleaners, then acoustic enclosures for noisy areas, hearing tests every 1 year. People have to be tested for their hearing ability. So specific tests are there which the doctors have to conduct for different frequencies. Okay, that also is given under the Maharashtra factory rules under dangerous operations, schedule number 24 gives very clear guidance that how these hearing tests have to be conducted. And those graphs have to be year on year, the graphs have to be analyzed, and then proper actions have to be taken. Either you have to remove the people from this area, or you have to give them better quality PPEs, you have to rotate the people, okay, or you have to put engineering measures like noise enclosures, etc. Then manual handling, where back injuries and muscles, which strain in the muscles, which happens because of vibrations and continuous use, repetitive use of those muscles. So vacuum lifters, cranes, manipulators, etc. can be provided. Where the toxic fumes are there, your extraction systems, they have to be very good quality and maintained well. Then scrap sorting, gas detectors, respirators should be provided. For machinery, we have to have proper machine guarding systems, lotto procedures, and proper training to the people. And heat, okay, heat, the wet bulb, dry bulb temperature, those ventilation and moisture control, okay, all those things have to be checked. Hydration, so proper water arrangements have to be made. All these are some of the risk control measures. Any questions up to whatever we have seen so far? Or any of the participants want to share any case study as to what happened, why it happened, what was the learning, how we can prevent the incidents by using your case? You can share.
Hello, sir. This is Ritika
Yes,
Goenka.
yeah,
Am I audible?
yes, please, yes.
Yes, sir. Sir, amazing session is going on. I don't have any case study per se, but I just have two questions. That first of all,
Hmm.
sir, a lot of time when we, identify such hazards at the company level, or we tell the company personnel that this is the issue that is happening, but they come up saying that it's very insignificant, nothing will happen, it's a very minor thing. So, sir, how to handle such argument, and how to ensure that even if it's insignificant, they're putting proper effort and their attention so that it does not become a big hazard. And second, problems are at the ground level, workers who are there, and when they are given training about hazards and the safety protocol, sometimes they reject the change of
Hmm.
because they see that they are not very comfortable working wearing PP kits, or they are not comfortable uh, with the gloves and all. So, sir, how to fight those organ like behavioral objections when we give them the idealistic approach or the right approach?
Yeah, see, first your question has got two parts. So first part where you said that the perception of some people to the hazard is, some people are feeling it is serious for them, but in the overall management of hazards, when the risk prioritization is being done, people classify it as insignificant, and therefore they do not pay attention to mitigate the risk. That is one issue. Now here we have to, whatever the HERA study is being done, it has to be done by the cross-functional team, so that different perspectives are taken. We have to also see the data. If somebody may be saying insignificant, but for the person who faces the hazard, who is affected by that, for him it is 100%. It is very significant. In fact, it is intolerable. So, in the whole midst of classification, we should not go only by the numbers. What is your SSPD number, severity scale, detection, probability of occurrence, etc. We should not go, we have to, there have to be some overriding criteria of assessing the risk. If something is legal, if something is, chronic issue it is going to create, if it is going to have domino effect, okay, if it is going to create some major, if previous history is there, then we have to take it as serious issue, the significant or substantial risk. And ultimately, there is a limit to how much you can do. You can always give them the examples, you can tell them cost of accidents related cases, or you can show some videos where how seriously the incident occurred, etc. So you have to make the factory manager sign off the HIRA document, so that the accountability is there with the factory manager. Tomorrow he cannot say after the incident that I didn't know, you didn't identify the hazard. Had you told me before, I would have taken action. Those kind of arguments can be prevented. But it all depends upon the culture, whether the senior people are, listening to the people below who work on these HIRA sheets. Many companies, delegate it to the young teams, shop floor teams only, and they use the system only for certification purposes. Their commitment is not there, not demonstrated by proper review of HIRA sheets. So there, you have a limit. Second question which you asked about the shop floor workers not following the discipline even though they are trained, because unless they see something happening, किसी को कुछ नहीं होता है, इतना रिस्क तो लेना ही पड़ता है, फाउंड्री में हम होटल जैसा काम नहीं कर सकते, like that arguments will come. But if the company's safety culture is deep into induction training, on-job training, proper monitoring through supervision, proper SOP compliance, PPE compliance, proper communication on every small incident that occurs, why it happened, how serious it could have been, near miss incident monitoring, and proper safety committee interactions, not just for namesake safety committee, but properly two-way communication, etc. If we do these problems, the managing change can be handled little more easily. But better than said, in the implementation, ultimately the top management to ground level, how the communication flows and how serious the people are, and what is the system practice culture that depends, that decides whether these things will happen. There are many tools like behavioral based safety monitoring, etc. But good BBS implementation requires first the organization to take care of all the possible engineering controls. Okay, because BBS is an administrative control. You observe, you give feedback, okay, and you make the person alert, you make the person sensitive to the hazard and tell him that next time you don't do it. But that is just an expectation that the next time the person will behave in a more safer manner. But that may happen, may not happen. So that has to be supported by proper engineering controls in the company and other systems. So we'll come to that. Pause for some time till we complete the course. You will get some of the answers to the change management and behavioral aspects also.
Thank you, sir. Makes sense.
Now let's come to the systems part. Okay. So OHS management, as you know, clause 5 in ISO 45001, it talks about commitment and leadership. Okay, and lot of leadership, requirements under OHS. Now the 45001, the beauty is lot of responsibilities have been entrusted on top management. So the accountability is there to the top. Then under clause 6.1 risk assessment. The risk assessment and hazard control, lot of guidance is given, and ISO 45002 and British standard 18004. These two standards give further guidance on HERA. Even the annexure part of ISO 45001 also gives lot of insights. Legal and regulatory compliance, for this you have to work with safety function, environment function, HR function, project management function, and all the law compliance is happening on the shop floor. So production people also have to get involved. Then comes training and competence. So this is not just inside the classroom, but for at least 5 to 6 days, the people have to observe what the seniors are doing, and then slowly people have to be put on the job under close supervision of the senior workers. And then once their competence is enough, they can ask them to perform on their own. Then comes emergency preparedness. So periodically updating the emergency plan, conducting mock drills, training people, and including the external observers during the emergency evacuation drills, etc. are done. That is required. And then the continual improvement through measurement, monitoring, corrective action, audits, and benchmarking, etc. etc. All these 6 elements of ISO 45001, they are very important PDCA for establishing a robust safety management system. So let us see this hierarchy of controls. Okay. So eliminate, if you can change the process, if you can change the materials, if you change the design, maybe the elimination is possible. Okay. The second is substitution, where less hazard. Okay. Substitution means you are continuing to work, but using the materials having less potential to harm. Third is engineering control, where technological intervention, okay, engineering controls, then Hoka yoke, all these are coming under engineering control. Guarding, that's part of it. Administrative controls are where SOP follow, the supervision, or some, performance linked to safety, then the permit to work system. Okay, all these are, or the PP audits. So some kind of those are administrative controls. Okay, the last one is personal protective equipment. Of course, those are required because they may not avoid the accident, but should the accident occur, the severity of the harm can be reduced by proper personal protective equipment. Okay, so this is what we say. First was remove the hazard, second was replace the hazard, third was isolate people from the hazard, fourth is change the way people work, that is administrative, and last is protect the worker with the equipment. So these are all 5 levels of hierarchy. Every time removing the hazard is not possible unless you stop production or unless you change the design. But other 4 definitely we can try and get. So elimination is most effective solution. If the hazard is gone, the risk is 0. Okay, so use robotics for pouring to eliminate worker exposure to molten metal, or redesigning the layout to use gravity fed chutes for sand. So that person is not coming in touch with the hazard. Second is substitution, highly effective step that reduces the risk at source. So use zircon sand instead of high silica sand, substituting binders with less potential. Engineering controls. These controls are always on and protect workers without relying on their behavior. Okay, so automatic stop. Okay, if some body part comes in the zone, that is all, the curtains, safety curtains. These are all engineering control. Install local exhaust, machine guarding, acoustic enclosures, thermal barriers. Okay, then administrative controls. These rely on human behavior and supervision and are less reliable than high level control. To implement job rotation for noise, daily safety meetings to discuss specific hazards, troop safety toolbox talks, signage and labeling. Okay, so be aware. Now, be aware is only he may be aware, may not be aware. Okay. Then PPE, protect the worker with PPEs, require respirators. Mr. Gopal Krishnan,
Yes, sir.
can you put everybody on mute?
Yes.
Because administrative control is not effective. We have to go for engineering control. Next is the PPE, the last line of defense. Even though it is the last line, it is very important, because even if the earlier things do not work, or if engineering control fails, sometimes it can happen. The machine guard itself may break, or some pokai may not work because of some electronic fault. In such situations, the person should be protected from all angles. So, hearing protection, then masks for nose, heavy duty gloves, then the flame retardant apparels in melting areas, etc. So these are some of the PPs, and good quality PPs regularly those should be inspected, and whatever the cost, we should not look at those items because these are very essential mandatory requirements, and the cost has to be inbuilt into the product cost, and we have to inform the customer that these costs cannot be reduced. So even if he may be putting pressure on price reduction, you have to give the proper breakup and tell him that these are mandatory costs, legal costs, and they cannot be reduced. So, different types of PPEs that we can use, I think most of you are well aware. Companies such as 3M, okay, they are very well known for their quality, durability, and reliability. So one can try if those are making sense with the overall economic and other technical parts. So some of the 10 commandments to summarize. One is wear your gear, because even if everything else is taken care, something may go wrong. When you are walking on the shop floor, the lot of hoists and cranes are there above, something may fall. Okay, breathe safely, so masks application. Inspect before use, so be alert always. Know your melt, so where the ladle is there, whether the molten metal is moving, how to handle, all that has to be seen. Keep out the moisture. So the you may use moisture for wet sand to be made wet so that it doesn't fly, but it also will increase the moisture in the air. So proper ventilation arrangements have to be given. Adopt good housekeeping practices for not only proper safety, but also it gives you the proper working environment where people are more happy while working. Be vigilant always, so not just the worker, but the supervision also has to be extraordinarily good, and you can use the technology like the CCTV cameras or others. Administer first aid, so proper occupational health center is required, not just the ambulance room, but as per the hazardous process related requirements, safety requirements, occupational health center with 24-hour doctor, compounder availability, ambulance availability, tie up with local hospitals, and shop floor first aid tickets, all are required. Follow communicable disease plan, where, like this COVID, that was communicable. So in such cases, lot of care has to be taken. Train to foster safety. So training has to be continuous. Dexterity centers have to be developed. Regular on-job training, induction training, repetitive, training on safety standards. Sharing the case studies of accidents, near miss incidents, and making people aware as to what can go wrong. HIRA reviews with experienced workers, all those have to happen regularly, then only foundry operations can be made safer. So as we were telling earlier, for implementing the ISO 45001, all the PDCA cycle has to be followed, proper consultant help, or the senior people, experienced people who have worked for at least 20 years in foundry, they should lead the safety coordination. Nowadays the MR word is not there, but still the system coordinator should be coming from maintenance, engineering or production background. He cannot be just an EHS officer, because EHS officer is working from a distance. Okay. Whereas the engineering, maintenance and production people, they know in and out of the entire foundry operations, and they can actually give justice to the safety system and make the operations real safer. So some of the benefits I don't have to repeat of implementing the system. It gives you strategic and structured approach. It provides evidence to regulators, customers, insurers and system auditors. Reduction in accidents, enhanced reputation and informed decision making. The path for implementation is an absolute starting point, management, leadership and commitment. Unless this is there, all the initial meetings have to be chaired by the factory manager, if not occupier. And then the proper gap analysis has to be done. You have to develop the documentation, train the people. Then operationalize and monitor is a longer duration. So it takes time for people to change habits. And then you have to go for auditing system. So this is the path which we have to follow. Then many people use behavioral based safety to take care. So where we have to have leadership in charge, we have to continuously engage the people, and it is based on fundamental training, not just to the observee worker, but also to the observers, the facilitators, the change managers, the safety standard owners. Okay, there are about 16 to 18 safety standards. If you go to DuPont safety management, there are about 18 safety standards. So step by step, we have to internalize them, make them part of our OHS management system, and create a safety culture where people are empowered and people are inspired to work for safety. So what are the steps? First is building the knowledge base, then through induction and on-job training, then task-specific competency based on base training, that is on-job specific training. Then toolbox talks, refresher training through continuous engagement, and then the BBS where you observe, you give the feedback. If the work is done well, you give positive reinforcement. Otherwise, sometimes you use negative reinforcement, including termination. Then data analysis, and all these workers should feel that the top management is really caring. So that is called visible felt leadership. Okay. Open communication. People should not be afraid of talking about hazards and near miss incidents. Strict adherence to all safety rules by leadership. There may be basic life saving rules as well as operational SOPs, do's and don'ts. So there no tolerance, okay, zero tolerance for safety uh, issues. So that has to be shown, demonstrated. At times, very harsh decisions have to be taken. Then only the other people get the lesson. TPM, good TPM practices in the company, they also are useful for zero accidents. Okay. So whether it is owning the maintenance, autonomous maintenance by the workers, or highly technical maintenance like Kobetsu Kaizen, it could be quality issues, it could be safety, it could be environment, it could be ergonomic hazards, it could be office safety, it could be learning from previous incidents. And then right in the beginning, whenever any engineering or new equipment purchase etc. is done, utilizing the previous experiences in new planning. So these are some of the elements of total productive maintenance. The companies who really use this get lot of benefit in accident prevention also. Okay. So this is how the various ways in which TPM activity helps safety. Okay. Now let us see how we can use technology for reducing accidents. So the first is the challenge. So challenge is the primary hazard areas in foundries are at shakeout stations, fettling, grinding shops, creating uncontrolled silica dust. There is a risk, high potential for workers to develop silicosis, leading to human tragedy, legal liability, and business disruption. So one of the solution could be high volume, high velocity, centralized dust extraction systems with local exhaust ventilation. Prime example of an engineering control. So this good dust extraction system is essential. The impact is significant capital investment justified by cost of non-compliance, because most of the foundries will be asked by the Directorate of Industrial Safety as well as Pollution Control to have proper dust extraction systems. Okay, dust levels can be reduced to below statutory limit, with this system. Second is challenge primary hazard areas. Tasks are manual lifting of heavy mold boxes, manual pouring of molten metal, and repetitive handling.
हे लगेच घेऊन ठेवा बरं का रे मिक्सर वगैरे सगळं
Mr.
आणि
Gopal Krishnan,
साठेल असं बघा कसला बॉक्स
Mr. Gopal Krishnan.
घेऊन ठेवा.
Yes, sir. I have muted all. Just you can unmute, sir. Hello. Hello. I have muted all. You can unmute and talk, sir. Govind Pitre, sir. Unmute everything. இதை பண்ண முடியாது. அவ்வளவுதான். Unmute எப்படி பண்றது? பண்ண முடியல. Govind Pitre, sir, you can unmute and talk, sir. Sir, you can unmute and talk, sir.
Govind, can
Hello?
you hear us? Govind, can you hear us?
When I unmute, you
Yeah,
are
now
again
it's okay.
unmuting
Now it is
everybody,
okay.
then that's creating a problem.
Okay, sir. Now it is able to hear, sir. Hello? You can proceed, sir.
Yeah, are you able to see the screen?
Yes.
Yeah. So now we have to go to the next aspect, which is proactive health monitoring, catching the invisible. Now, how do you catch the invisible? That is through proper medical examination of people, strict only to statutory requirements. Okay, statutory, it is left to the doctors. Okay, the government through the laws, they have not specified what medical checkup has to be done for which workers. They have left it to the medical doctors. They are given 3-month course, AIHC course from central this safety schools and CLI, Central Labor Institutes, and they are qualified to decide in which factory, which hazards, which medical checkup should be done. Many times what happens is the HR people and the top management, they tell them that you design a system which is cost effective and which will fulfill the legal requirement and which will not put us in trouble. So then what happens is it becomes a ritual and it becomes a cost intensive activity rather than value adding activity. So if the management is really committed to safety, they will really get proper reports done by good hospital and then analyze them year on year and then identify if there is any notifiable disease and take preventive actions. So this is where the actually felt leadership or the sincerity and commitment of the top management demonstration comes. So chest X-rays for early detection of silicosis, non-negotiable for dust exposed workers. Then audiometry for noise related induced hearing loss. Then spirometry or the pulmonary function test. So for lungs, blood test, screens for lead and manganese toxicity. So urine and even the certain screening which is done for urine tract. Okay, all those systems, all those are done to ensure that the toxicity has not entered in the blood. Okay, these are all various medical checkups which are conducted. There are certain challenges. So we have to use data driven heat stress management. Okay, so radiant heat from furnaces, heat cramps and exhaustion, heat stroke, sometimes it can be fatal. Okay, heat exhaustion can be fatal. So the technical solution is real-time wet bulb globe temperature. Monitors can be installed in critical areas. Mandatory breaks in cool rooms as well as open air, cold water, okay, or sometime they get in air conditioned rooms and then come back and start working, something like that. So these are some solutions. Similarly, the for zero harm, okay, the top management should be visionary. Okay, if you are a compliance oriented company, the safety culture will not come. Then you will only keep fulfilling the Factory Act requirement. You have to go beyond. After the law compliance is there, you have to use ISO 45001 PDCA very effectively. You have to implement good practices from industry and also use the tools like behavioral based safety, human reliability assessment, and technological applications like robotics, etc. So, the top management with zero harm, okay, the leadership plays very important role, as well as worker participation is very important in hazard identification, risk control determination, incident analysis, near miss incident reporting, then HERA updates, on shop unsafe condition, unsafe act identification, implementing small safety kaizens, okay, participating in toolbox safety talks very seriously, safety committee meetings, observation feedback mechanisms, everywhere worker participation is mandatory. Leaders on the shop floor, so at least every week the factory manager along with production, maintenance and HR and safety officer should take around, identify unsafe conditions. If they find something serious, immediate instructions to be given, and by end of the day, correction measure should be implemented. Asking questions, listening to concerns, leading by example. So if the factory manager or a director is taking around on shop floor, he or she also should follow safety rules, and safety PPEs also should be worn by that person. Then behavioral based safety. So peer to peer observation and feedback. Before you go to peer, at least the supervisor should do the proper supervision, observation, giving feedback. Then focus on coaching rather than punishment. Of course, 1 or 2% situations may ask for punishment, but 98% focus should be on understanding, trust, coaching, teaching, learning, understanding, etc. Empowers every employee to be a safety leader. So, safety policy also should be drafted in such a way where you give the direction to the all the people, saying that it is not one man, one safety officer or one safety system coordinator who is going to implement the system. It is the total safety management, total employee involvement in safety management is something which is very essential. And nowadays people are following ESG, environment, social governance. In that also, under social, occupational health and safety is very important. Currently, in the disclosures, the data that is demanded is more of reactive data, lost time injuries, lost time man days lost, and frequency of accidents, etc. How much cost was there and how much compensation was paid. So these are the leadership and essential indicators under the safety. In principle 3, employee well-being, essential indicator 10, 12 and 15 of ESG under BRSR, these data are asked, but those are more of reactive indicators. In order that we make zero harm culture, we have to focus more and more on proactive planned safety systems. So some of the good systems of Bharat Forge, which is one of the leading steel manufacturing company. So they have implemented ISO 45001. They have proactive HERA and it is supported by third-party interventions, consultants help, third-party audits, empowering the workforce in a limited way, technology-enabled safety, industry 4.0, 5.0 applications, holistic employee well-being. Then they are using rigorous processes for high-risk work. So safety standards have been developed. Comprehensive training and competence. So 5 people in safety department, they focus on regular training, BBS for cultural transformation through proper guidance from the external guides, and leadership driven safety culture where Mr. Managing Director Mr. Baba Kulkar Kalyani himself takes rounds on shop floor and directs the people. There are executive committees which meet every month to review the safety performance alone and give sufficient time for deciding the resource requirements on safety. So these are, I would not be able to detail out. Similarly, many good systems are there in other places also, electro, steel and others. This is related to AI engineering, which is, AI engineering is one of the listed entities in safety, in foundry operations, and they are also having very good practices for safety management. So the way forward is IoT and real-time monitoring using the internet, wearable tech. Then we go for robotics, automation, digitization, then virtual reality, augmented reality related training and applications. These are all ways in which you can look safety in futuristic way and use technology for people protection. Okay. So there could be some challenges for MSME sector, but ultimately the challenges cannot stop us. If we are committed, we can create money through our proper management and utilize for people safety aspects. So some of the key takeaways from today's program, one is OHS is an integral part of sustainable operations. As I told you, it's a strategic investment in the business future. Always try to move safety solutions higher up in the hierarchy. That is, if you are relying on PPE, add some administrative control, go for engineering control, substitution, elimination, etc. Health hazards are as critical as safety hazards. So in foundries, apart from the injury prevention, ill health prevention is also very important. Then leadership and culture are the ultimate foundation. Emerging technologies are shifting the paradigm from reacting to incidents to predicting and preventing the exposure. So this is where the major change is going to be. The future is predictive and not reactive. Okay. So let us cast safety in our culture and maintain it like a strong, robust with high shock absorbing capacity. So that's what I have to share. If any questions are there, you can ask. Mr. Gopal Krishnan, you can conduct the Q&A session.
Okay. Any questions from participants? Question and answer sessions. Okay, then we can go to the vote of thanks.
Yeah.
Good evening to everyone. As we came to the conclusion of this webinar on occupational health and safety aspects of foundry operation, it is my privilege to propose the vote of thanks on behalf of the Institute of Indian Foundryman, National Center for Skill Development, and EHS Committee. First and foremost, we express our sincere gratitude to our esteemed guest speaker, Mr. Govind Pitre, trainer consultant, for sharing his valuable knowledge, practical experiences, and experts' insights on occupational health and safety in foundry operations. His sessions greatly enhanced our understanding of workplace hazards, preventive measures, and the importance of building a strong safety culture in foundries. We would like to also record our heartfelt thanks to Mr. D.G. Paharpa, Chairman EHS Committee, and Mr. C. Satyamurthy, Co-Chairman EHS Committee, and Mr. K. Dayaran, Chairman NCSG, for their guidance, leadership, and continuous support in organizing this meaningful program. Our sincere appreciation goes to the organizing team from NCSD and EHS Committee for the dedicated efforts in planning, coordinating, and successfully conducting this webinar. We also thank all the participants for their active involvement, thoughtful questions, and the enthusiastic participations, which made these sessions interactive and enriching. With this, I once again thank everyone being part of this today's program and look forward to your continued participate in future initiatives of IAF. Thank you all. Have a safe and pleasant evening.
Thank you, Mr. Gopal Krishnan and
Thank you, sir.
Pune office
Thank you,
to
sir. Thank you,
organize
sir.
this. And thank you for giving me this opportunity. If any specific in-depth sessions are required, please do let me know. Thank you.
Yes, sir. Yes.
Sir, Ashokal Suru here. It was really a great presentation and a great discussion. Thank you very much.
Thank you.
We will distribute your profile to all the members, sir. Those who are interested,
Okay.
will come forward.
Thank you, sir. Thank you.
Thank you, sir.
Shall I leave?
Yes, sir. Yes, you can leave, sir. I am waiting for others to leave.